My name is René Neumann. I'm working together with Karouche, and I'm the Director of Solution Engineering. And over the next couple of minutes, I'm trying to spend as much time directly on the demo as I can. I have a few slides in the beginning, and then the later part really is going to be mostly product-driven. During the first demo, I want to talk to you a little bit how we can bring immutable principles to your branch deployment. And essentially what that means for us, right? What does it mean for maybe for an enterprise customer, and how can you achieve that? So briefly explained, where are we coming from? What is a challenge? As Karouche has mentioned, we as a company, we grew up pretty much with the hyperscale data center environments and helped the hyperscale customers to literally to provision their data center environments. Their structure is mostly around pod design nowadays, so where they just have a set of rows or a set of racks. They bring the entire setup, and that gives them everything what they need to just serve more customers out. So what we see now with more and more enterprise customers, though, is that pretty much the same functionality, the same desire is coming into the enterprise data centers as well. And that is mostly driven around private cloud deployments. So where customers are coming back from the public cloud, but they like the flexibility which the public cloud gave them. They just want to have that in-house. So they're starting to build out private cloud environments, and they're looking at ways of how can I automate the entire setup of a rack, of a row of racks, including storage and everything else, right? And if you're starting to think about that one in your data center, then it's just a small leap to say, okay, I want to actually have exactly the same capabilities in my edge data centers, or maybe in nano data centers, which are maybe only a half rack, or sometimes just a small little server somewhere far away in the wilderness, let's put it that way. So what all of these data centers have in common, if you look at them as data centers, is they have overall the same requirements. You need to manage your compute, you need to manage your connectivity, your network, you have to manage the security, but you have to do all the operational technology stuff as well: power, cooling, sensors, physical security. All of these challenges are pretty much the same. Now, given hyperscale data center looks completely different to a nano data center, but from the outset, the challenges which you have are very similar. So essentially what we have learned in the hyperscale data centers is what we want to bring to your edge data centers, to your nano data centers, or to your enterprise data centers, wherever you might have it. So we have multiple products. Karouche mentioned that already a little bit in his part of the presentation. Essentially, we have hardware which fits in any of these categories. What the devices have is they run the same operating system stack. They provide the same level of functionality. So whatever you have designed and deployed in your data center, in your enterprise data center, you can directly transfer over to any of the other appliances. So that means whatever solution you deploy for your enterprise data center, you can more or less directly deploy into your micro data center, which is maybe at the bottom of a 5G tower, down to a nano data center. And the solution will give you the same level of management, infrastructure management, or security management. So ultimately, what is the goal around infrastructure operations? What are enterprises really looking for, and hopefully we can answer those ones for enterprise customers. So for one, from an operational perspective, it needs to be secure. It starts off with what vendors are you using? How do you get the boxes on site? Is a physical location secure? And then as soon as the units are there, then you're starting around the whole software stack as well, right? You boot the devices up, you have to make sure that the software wasn't tampered with in any shape or form. Then you have to apply your your applications, your security standards, and so on and so forth. The whole process should be simple, should be streamlined, as we have seen. If you have 5, 10, 20 different solutions which all need to come together in a site, you want to have a streamlined process on how you can roll that out, and most importantly, how you can repeat it as well. Should be scalable. What we see with most of our customers is, let's say 10 years ago, most customers would focus around their 2, 3, 4 enterprise data centers, which they might have globally, and then they had a couple of major branches and offices they needed to deal with. That specifically over the last couple of years, that has been far more distributed. We see far more smaller offices with 5G coming along. You see really these micro data centers or nano data centers popping up all over the place. That could be beside a train track, could be at a LG tower, could be in an industry or mining facility or something like it. So literally infrastructure is popping up everywhere, which needs to be connected in any shape or form, literally. And then the last two, the solution should be sustainable and sensible. Sustainable, ideally hardware should run for longer. Again, in the data center, let's say a server would last 2 or 3 years. That model is slowly but surely outgrowing itself. Servers have quite a long lifetime nowadays. So what we really see, in specifically in the networking space as well, in the communication space, is that the physical hardware in itself is not changing as much anymore. There's no need to change the hardware in itself anymore so much. Really, most of the changes are driven around software, about changes which are happening in the security stack, in the application stack, and those need to be rolled out then to the different sites. But if you look at it from a pure sustainability perspective, there's typically no real need to really throw out the hardware. It's more about replacing the software.
Is that still true with vendors? Because a lot of times the hardware replacement cycle is more about the availability of replacement parts than the actual technology itself. Are we seeing more commitment from vendors to sustain the ability of repairability of the hardware in the long haul like that?
If you would ask me, yes, it's definitely something which will come more and more into the market space. For one, it's driven purely by the lack of parts currently available. Right, more and more vendors are forced themselves to support their own hardware for longer. The second part is specifically in Europe, at least, there is in the consumer market, there's now a requirement that all vendors need to be able to repair their products for 5 years. And what we have seen over and over, what is typically popping up in the consumer space sooner or later will come over into the enterprise space as well. So at least companies in Europe will expect over the next couple of years to appreciate the hardware which they have over a longer period of time. Another point to that is it falls directly in line with green goals as well. Uh-huh. If you look at the CO2 footprint, hardware is typically the biggest chunk of it. It's not the running of an equipment. I can easily run a 5-year-old server for probably another 10 years before I reach the same CO2 footprint than replacing it with a brand new one. So I think there are multiple reasons there to really run your hardware for longer.
I think most of the places that I've worked had anywhere from as low as 3 to as much as 7 years on a hardware cycle. And I've had very few vendors that would give you repair parts after 7 years. So what do you think the new long-term life cycle like this will be in hardware?
So there are two points here. I think part of the business strategy of some vendors is that I make money on hardware. So shifting out the hardware is actually part of that strategy, because it's they're not charging necessarily for the software ARR. But if you pay the same amount of money to them without replacing the hardware, that actually means better margin for the vendor. And so I think it's half of it is business model. The other half is that technology, with Moore's law and the amount of compute that is actually needed to process certain types of traffic, not all traffic, but certain types of traffic, does warrant the need to put or replace the technology, not because the business model says so, or the tax write-off piece, but because you actually need to go from, let's say, 100 gig to 200 gigs now, and that just needs new technology thrown at it, because otherwise you need two boxes. The other one that is, I think Renee actually answered it really well, but there is this math out there that some people do that say, replace your servers every 3 years because the chip is twice as fast, therefore it burns half the electricity. So then it's paid for itself. But from a CO2 perspective, it hasn't paid for itself. But that's one of the maths that server people use to keep selling servers every 3 years. And then you have a whole bloat of servers on the secondhand market, which there is another company, actually is in Fremont. They take all the secondhand servers and redeploy them for the next 7 years in secondary market at half the price. So it's kind of like the new car, used car market in this environment.
Yeah, I may have taken advantage of that.
So in the primary market, though, it's really hard to get that support and repair after 7 years. So where do you see that number moving to in your prediction model here?
I think if you use general purpose CPUs so that everything looks like an Intel server, DRAM and storage with the same interfaces and not these specialized chips, then it's about how much you want to future-proof that piece of hardware with overhead, or with enough headroom. Headroom is the word I was looking for. Left, such that in 7 years from now you still can address the bandwidth needs that the networking piece needs to do. So I think the commitment it's a balance between the technology just not being obsoleted, but at the same time the needs, and then not overbuying as well. So I think that's the equation that generally gets to be solved. And I think 3 years is too fast. 5 to 7 is probably the right number, because that also matches up with the depreciation curves from a tax purposes. Going beyond that is probably not worth it, at least in today's industry. But architecturally, I think the architecture needs to support a 20-year sustainability, right? That you can choose to replace the hardware, but maybe not.
I'm not sure if we can go over this 7 years, because there's really stuff happening on the hardware side as well, right? But I think ultimately the goal for enterprises should be is, just because I'm replacing a hardware, I don't need to change my deployment model. Yeah. Or my deployment scripts, right? It should be all done from a software layer, and there's no reason from a vendor perspective to support a 10-year-old hardware if the hardware is still available. There might not be, at least on the software layer, there mightn't be any repair parts anymore available, because it's the technology just has moved on. But at least I could run the hardware as long as it goes. I personally have seen with one customer, they gave more or less a standing ovation to an old fax server, which was running for, I think it's that point 17 years, and was on for 17 years running nonstop, and then at some point it just blew up. So they took it out of the data center and had and hold a ceremony for a couple of minutes.
Yeah, if you don't schedule maintenance for the hardware, it will do it for you.
Correct, at some point, right? So now let's really slowly but surely getting into the demo, because I want to show you what we have. So what I'm going to show you during the demo is how we're trying to address those needs, and how you can use our platform to manage your edge infrastructure, specifically around build, destroy, and rebuild. Specifically, the use case which we're going to demonstrate is around the initial deployment, but you can use the same principles to say 6 months down the road, okay, I need to rebuild the site, and you can use exactly the same steps which I'm doing today. Then in 6 months' time, in 12 months' time, and completely rebuild the site. So why might that be interesting to you? Okay, you need to do it during the initial deployment, quite obviously. But you might want to do it if you had a security incident in a company, and you might just say, okay, I might be better off just rebuilding all of my sites. Right, I've done my initial investigation. I know roughly what happened. Now it's cleaning up. How do I do that effectively? Next one is, how do I deploy changes holistically? Right? How do I manage that in the cloud environment? It's depending on the application, but it's mostly done by actually destroying the server and spinning up a new server with a new sets of instructions and settings. And we can do something similar there to physical appliances as well. So that is what I want to show you, and that is where we have the demo. So roughly, how does it look like? How does a branch look like for most companies today? So on the right-hand side, you typically have your applications. Those might be SaaS-based applications. They might be in the cloud or in your data center enterprise, and your branches, your edge locations, have some are connected to them through an internet connection. Typically, they have some form of cable connection, could be cable modem, VDSL modem, fiber, MPLS, whatever you might have. And more companies have a wireless connection, a 4G, 5G connection as well. And then in the branch side, you then have either an SD-WAN appliance, or you might have a next-gen firewall appliance with a switch. And then depending on what the branch side is doing, IoT devices, compute, or normal clients, which are deployed there. So how does it change if we come in? So for one, we would typically replace the 4G, 5G device, the 4G, 5G modem. You can use our appliances to perform exactly the same tasks. And but what we bring additionally to purely the wireless connectivity is we directly bring as well a dedicated out-of-band management network to your branches. For those of you who are quite familiar with enterprise networks, or enterprise data center deployments, it's probably a very, very familiar concept to you. Most enterprise data centers have a dedicated management network and or out-of-band network, which provides them access to their equipment in case of a catastrophic failure of any of them. It's typically used for the initial deployments, break-fix scenarios, change management. Really, the out-of-band network is hugely dependent on the, I would say, on the maturity level of the company, how often the out-of-band system is used. So we as ZPE, we can directly bring that to any branch which you have, to any edge location, regardless of the size. If you go back to our data center model, if you have a nano data center, then you are getting exactly the same capabilities as if you run it in an enterprise data center. So we can give you the same capabilities there. Here in the picture, you see on the right-hand side as well our own ZPE cloud, our service router devices, in this case, the board SR, are typically managed through our ZPE cloud, can be either run as a SaaS, which we provide as an on-premise solution as well, or if you don't want to go with our ZPE cloud instance, then you can have as well your management in your own data center. It's absolutely no problem. It's extremely flexible on that side. So that is roughly what we're looking at for the demo. Just a brief picture, that is the unit which we are using for the demo, just to give you a quick overview of how it looks like. There's a couple of serial ports, a couple of network interfaces, and as I mentioned, it has the LTE capabilities as well. It takes up to 2 active LTE modems, which you can use for either out-of-band or even your in-band connectivity as well. last picture, then we jump into the demo. It's just a different way of looking at it. This is more or less a rack view of what we did. Here again, you can see we replaced the LTE modem with our own device and provided to that customer environment a dedicated out-of-band connection, enabling the customer, for example, to already use rack PDUs and UPSs, which were deployed on site. But up until that point, they weren't really used or utilized or managed. So we brought all of that into one unified system and then helped the customer to manage and deploy the rest of the devices like the firewall, the switch, and their server. I'm not going to spend too much time on this one. We're going to jump forth and back here. That is really the demo which I'm going to show you. The demo is, for this part, 2 videos. We can jump forth and back. I have access to the environment. So if you want to something specific, mention it to me. I can then jump directly into the product, show it to you. Absolutely no problem. Okay. Otherwise, just ask a question throughout, and I'm going to comment the video as well. So what are we going to see during the video? It's essentially a deployment scenario. So what you have is smart hands arriving at an edge location. They do the physical installation, and at some point during the installation, our board SR is turned on. At that point, it will use any kind of network connectivity and reach out to our ZPE cloud. It comes online. You as an administrator get a notification, your device is now online, and you can start using it. Now, the reality is at that point, you might not really know in what state the unit is. You might not know necessarily what firmware version is on it because it's a brand new unit. You might not really know if somebody has already configured something or if any other changes were done. So as a very, very first step, what we're going to do is we're going to push down a firmware version to the device, which was pre-agreed by you. And we're then going to format the entire system, wipe it, reinstall the firmware. Our appliances support UFE with signed operating system, so we can be sure it's a valid firmware which we are applying. So we do that, and as soon as the unit comes back on, then we can start pushing the configuration down to the device. So that is the first part here on the left-hand side. And on the second part of the video or of the demo, we're going to do exactly the same thing to a physical appliance, in this case, a Fortinet firewall.
Do I need, as a customer, prepare your box up front? So do I have it to have in my lab and then put in, I don't know, some pre-configurations? Or is this all prepared from ZPE and this can be then directly shipped on site from you without me having to do anything up front with the box?
It's a very good question. There's nothing what you need to do. We are currently even in the process of providing our customers, when they want it, with international SIM cards, which we pre-install before we ship the unit out, so that the units are really ready to go when they arrive at the location. So the whole idea about it is really, we as ZPE ship the unit wherever it needs to be, in any country in the world. And just somebody smart enough with a screwdriver and understanding instructions on how to do the cabling unboxes the unit, rack mounts it, plugs the cables in, and powers it on. And the rest you can do as a customer directly.
In best case, with LTE SIM card already plugged in, not even a cable is needed, just power, yeah?
Correct.
Okay. Great.
If it does that, will it kick off this process in the guy's hotel room when he's making sure things are right before he's arrived on site? Or can you control when the process kicks off? When the home occurs?
Yeah.
No, it's a very good question. So currently for the demo, I'm doing everything manually. Okay, so I know that the device is online. I'm starting to push the first firmware version, and you're going to see that in a second. I started the video just because of the time. So what you currently see here is our ZPE Cloud instance. I've just logged in, and that is the device which we're looking at. The host name comes up with the default name, NodeGrid, and you can see actually it's currently in failover mode, meaning it's connected through LTE. Yeah, so its main connection is typically ETH0. It's predefined. You can change that if you want to. And the device detects, okay, I can't reach the internet through LTE0, through ETH0. I'm using the LTE connection now, and I can directly see it. Because it's the very first time that I connect to the device, I need to change the password as well. So that is currently what you're seeing here. Now, coming back to your question, I do all of that manually. Yes, you can automate it as well. There are some triggers already in our platform where, for example, you can say, okay, apply that script and the unit connects for the very first time automatically. Yeah, just do it. And there's another one where the device might connect. It might be brand new. It's in a special area, which we call available. And when you move it over to enrolled, again, it's another trigger. So there are multiple triggers which you can use, or you can use an orchestration tool as well. So what I've done just here a second ago is, and that might have been a little bit fast because I was talking, is I went to an area which is where our devices are listed. I selected the device and applied a specific profile. And that profile will now do what I mentioned beforehand. It told the NodeGrid, okay, download the firmware, restart, do a firmware upgrade. While doing that, wipe the entire disk, reformat it, apply that specific version to it, and then come back up. For the video, I sped up the process a little bit, but you could already see it formatted the disk and applied the firmware version. As part of our standard default, essentially, we already deploy some basic firewall rules. We configure the LTE connection if it's available and bring the unit up. So what you see now in our ZPE Cloud is I went to profiles, operations. I can see that the task was completed. And when I click on the task, number one, I can see the code which was pushed. But at the bottom, you can see as well, sorry, that window, you can see the output of that script of that task essentially. Okay. As a second step, now I'm going to apply the configuration to the device, and the steps are always the same. You have these profiles there which you can select and then apply to a device. You can do that on a once-off basis. You can have it on a scheduled basis. Can you
like enforce, like I'm assuming it would measure, like for example, if somebody changed something on a router or whatever, can it like auto enforce it essentially? So if it identifies a version has changed, it can push the right version out without.
So directly. So directly in our platform, we don't necessarily have that as of today, but that is in the second part of the demo. That is in where we are talking about closed loop automation, essentially where you could have quite easily a system, and that at a previous demo at the Network Field Day, if you're talking specifically about the NodeGrid, you can run on a scheduled basis a configuration dump. Check that into Git, for example. If there are changes, then that could be used as a trigger to roll back to a NodeGrid state. So our entire platform in itself is built around APIs.
To that question, actually, and this is what I was thinking to mention, is that this first demo is putting immutable principles into action, meaning that we're assuming the infrastructure is not secure. We're wiping everything clean. We don't even assume any state on the routers. Even the routers will be re-imaged. In many customers, they even want us to change the BIOS of the router to their own BIOS that is deemed secure to address the risk of physical transportation. You could say it's on a truck. Somebody could have messed with this thing and installed some sort of a Trojan on it. So supply chain security risk management is actually one of the reasons that we get used, that assume that once the infrastructure arrives, it's got bad stuff on it. Wipe the entire thing clean, including ourselves, and rebuild us back from a known good image that we store in our extended storage in the cloud. And the same thing applies if the network, let's say, is infected or there's some sort of a issue in a piece of equipment. Let's say ransomware principles where you restore from backup, right?
Yeah.
So you assume that there is a known good config in the network as code CI/CD pipeline, and we say, okay, push a button, and that entire infrastructure gets redeployed within 30 minutes to an hour, and you're back online again in that last known good state. So that's really what this demo is about.
Yeah.
Thanks for that question. I appreciate
that. That makes sense. And so theoretically, it's kind of like configuration database, yeah? It's a known good, and then it can, but it still requires the person actually physically press the button to change it, or is it? Or you can time it.
So you can. It's trigger based. Everything is code, right?
Yeah.
So it's whatever you wish it to be. In fact, maybe this is a good time to mention for the Ukraine situation, right? One of the asks of us 3 weeks ago now was the internet lines were going down in Ukraine, right? And so the ask was that if the internet gets cut from this data center, and you can, ping every 10 minutes, if that happens, wipe the entire data center clean, right? So that the assets don't fall into the wrong hands, right? So it can be trigger based. It's whatever you wish it to be.
Let me jump slightly back. Essentially, the configuration of the device of the node grid appliance just completed. I just showed again, you get the full output of the changes which we applied to the device. And I then used our cloud platform to log in to the web UI of the device in itself. So you can see here, the device is now configured. And pretty much here as the last step is I'm just showing standard out-of-band capabilities. I have the 40 gate configured. You have access to the console interface, which I'm actually going to use in the second stage of the demo to configure the device. But you're going to have access as well to the web UI of the FortiGate, for example, because it has a dedicated management interface and so on and so forth. So at that point, without doing anything, the bare minimum what you have is now you have a secure platform which you can use to start doing your operational tasks on site. So that is literally the first part of that demo is how our appliance arrived on site, was completely wiped, rebuilt, automatically connected, and then redeployed. And yes, you can either do everything manually if you want to by pressing the button, or you use automation for that, or triggers which we have in our platform to fully automate it. Okay. I just thought for visualization purposes, it might be easier to do it manually. Let's put it that way. So in the second part of this demo, I'm going to start it again. We're starting again in the ZPE cloud, but this time around, we're not going to look at ourselves, but we're going to look at a target device. Specifically, we're going to look at the FortiGate firewall. As a very first step, I'm just going to log into our own web UI and going to show you that we access the FortiGate web UI in itself, the management interface, and that it's still on the default configurations at that point. And then we're going to use again the ZPE Cloud platform to do exactly the same thing what we did with ourselves, essentially, to the FortiGate. We're going to reboot it, wipe the disk, apply good known firmware version from FortiGate to it, apply configuration, a base configuration to the FortiGate, so that it then you could fully configure the FortiGate if you want to, or you can just bring it up to a state so that it's good, that it can connect to its own management platform, and then it's enrolled to your central management there.
So if I get it right, this is a random thing. So FortiGate is here just an example. I could create more or less for whatever box I have a similar script. It's just a matter of getting the automation right. And do you share this across your customers? Or do you have kind of a I don't know, forum marketplace where, I don't know, somebody has vendor ABC already fully working script or kind of a repository style?
Yeah, like pre-configured. So they already go ahead. It's like, all right, here's everything for Cisco ASA firewall. Here's for Fortinet. Here's for.
I guess the well-known vendors, somebody of your customer has already done.
No, absolutely. By the way, I love that question. That's actually basically our North Star, right? Our North Star is that the popular vendors, the Palo Altos, the Fortinet, the Ciscos, the Aristas, those are all, you can say the top 10 vendors. There is already a blueprint and a set of scripts. The scripts that we have, because we are open, the scripts can be our own scripts, but then people want Ansible scripts. So it's actually a large matrix that needs to be developed. The goal here is that we already have a starting point. There is also professional services that we get involved with. But I think ultimately for this to be mass adopted, we do need that community that you mentioned and a forum. So those were actually the 2 points that I was making internally on my strategy slide, is that's what we need to go do. So it was like amazing.
Amazing segue. Now, to add to what Koos is saying, I can only build on it. In terms of work which would be required, it's actually not as much maybe as it might sound, because we can directly leverage existing automation frameworks. I have successfully tested standard Ansible modules for Cisco, for example, and they work perfectly well over the console port. There are a couple of smaller things which you need to be just aware of to get it to work. Because speed, for example, is a big issue, right? You're dealing with 9,600 baud normally if you don't change it. But in general, it just works. There's no big change there. So if you're already familiar with an automation platform, then there's there's a high likelihood that you could reuse that knowledge directly with our platform as well. So we're very likely going to build on that and then make that available to our customers as well. As of today, as Koos mentioned, is if a customer has a specific question, they can come to us. We help them. We help them writing the first couple of scripts, getting up onto their feet, and we share then whatever we currently have already with them and with the community.
You have already solved the standard problems like not pasting 4,000 lines of code to a serial console at once. Yeah, staging that a bit.
Yeah. Correct. Right. So ultimately, the hard part is already done. So at this point, it's now the second hard part is, okay, what is specific to a Cisco ASA, for example, or to Fortinet or to Palo Alto, to get to certain things done, right? And if I want to, and if we have later on time, I can easily share or show you as well the script which I used for the Fortinet, for example. So the commands, if anybody is used to Fortinet, it's relatively straightforward and easy to read, and we can just expand from there as well.
And Renee, those scripts, are they zero up scripts, or are they desired configuration push? Are you pushing actual CLI commands, or are you sending a desired state through like an API?
So the best way of doing it from what we have seen with our customers is you want the console interface to bring the device up to a specific point, right? Console speeds, or the console connections have some limitations which we can't really work around with. Speed is one, and for example, you don't really have APIs. So meaning around the CLI or the console connection, we are dealing with standard CLI commands.
Okay, and then I saw TFTP being used there. Is that just for demo purposes?
Yes and no. So our platform really provides you with all the necessary tools to do whatever task you need, right? The Fortinet, for example, if you want to what we did with the Fortinet is we rebooted the Fortinet, and during the reboot process, there's a point where you can press a key button and then a menu comes up, and that at that point, it allows you to download a specific firmware version and wipe the current installed boot disk. Okay, so it's a process at that point. The Fortinet requires at that point that the firmware version is available on a TFTP server. Okay, so
so that's a limitation with the third party.
Correct. So, but and I'm going to be honest, specifically on network devices or anything like it, you will still come across all of these weird little limitations all over the place. And that is exactly the issue, what makes operation and deployment of these devices so complicated. You still need TFTP somewhere, and TFTP needs to be local to the device. So where do you set up safely a TFTP server just for that one task and then rip it back down, right? Or another appliance
you are saying more or less you have us covered. If we need TFTP, SCP, whatever it is, I can run it on my ZPE cloud, maybe preload the image already to the boxes so that I don't have to download them on a very small connection, maybe on site, ship it on site, and then use it more or less just local to upload the image.
So we call that staging, right? So the platform, because it has disk and it has the networking portion as well as serial portion, it can hold all the images that you need. It can run the script as if you were typing it locally. And it's also your TFTP server. It can even give the DHCP addresses if the devices are limited, but is as if you were virtually present over there and doing everything yourself, and you set up the TFTP on your laptop. You don't need to do any of that stuff. The box has all of those tools for you.
We have all been there, TFTP over a very, let's say, buggy line that has a lot of latency and maybe a packet loss is horrible.
And the other point is that this box is generally local on your local LAN. You don't have to do it across the world. So even if your internet lines get cut and this thing needs, because the device maybe went down, maybe your SD-WAN went down and everything is relying on that SD-WAN being up. How do you bring it back up, right? And so the box can say, hey, this thing went down. Let me start from scratch and rebuild the entire thing and bring my branch up automatically. It can do that. And
you mentioned staging. So I assume then, like with using Fortinet as the example, so you would get it up so that it has enough connectivity to get out to the internet, and then it is, for example, taken over by a FortiManager if that's what the organization
100%.
is doing, and then it's managed with that.
100%.
Okay.
Yes.
Exactly right.
And then at the end of that, you turn off TFTP
right
everywhere.
And it can do that.
So assuming you're doing that staging option with pre-configured or pre-installed firmware, you're going to skip that initial setup process of wiping the device. I would assume that's an optional step.
Yes, and you're correct. And look, ultimately, what we are and what we're to show to our scenarios or use cases, right? We are the platform. We are not an automation provider in that sense that we have predefined playbooks and that is what you need to use to do it. We give you the capabilities of deploying your own playbooks, deploying your own automation, to use the tools which we're providing to your own needs. We are going to work on playbooks as starting points for our customers. We have them already with our professional services, for example. But ultimately, if you want to deploy your own playbook, your own automation process, then that is entirely up to you. That is exactly what we want to do, or what we're offering our customers.
What about vulnerability management on your own systems? Obviously, you're running software that needs to be updated or patched. How does that impact the third parties that are running on your systems? How does, what's the process there?
I'll answer a couple of those, and Renee, you can build on that. So that's actually the other reason that these tech giants actually worked with this platform. And in fact, many of the features were built because of those requests. So this platform, as an example, the security of the physical security of this platform, it was imperative, starting with an encrypted disk, right? So the disk is encrypted, the encryption keys are on TPM, and it's actually one of the most implementations of secure boot that I've seen. In fact, I think it's done. A lot of people have TPM, but they don't even use it, right? So the BIOS is locked. You can basically tighten this thing up to the point that if you forget the password, the entire thing is useless, right? And you have to throw it away, type of a thing, right? So it's basically starting from the foundational piece, that the security aspect. Then on top, in many cases, as I mentioned, people actually replace the BIOS because you can introduce some Easter eggs in those as well. So it's about starting with these golden images at all levels, and then assuming that everything that's on that platform is no good, including ourselves, and rebuilding ourselves with the hardware root of trust, as it's called. So we trust that the disk and that TPM is secure, that we have to trust something, but then everything else we can put back onto the device and rebuild.